welcome everyone to the SIMIODE textbook panel. It's my pleasure to just introduce our panelists, and then we'll get right to the discussion. So advance the slide. Here we go. So we're really pleased to have several people who have been working with the SIMIODE textbook, and possibly others in the audience who may chime in the chat. But in particular, we're really excited that Kurt Bryan, the author of the SIMIODE textbook at Rose-Hulman Institute of Technology, is here with us today, and Jean-Marie Linhart, and then Maila Hallare and her student Angela Wang, and then Maryke van der Walt, and at Westmont College, Catherine Kozak at Community College in Flagstaff, and then AJ Alnaser at Florida Polytechnic University. So I think for the introduction, we're just going to go in this order, so that keeps us organized. About 5 minutes for each presenter, or each of the panelists, to just kind of give us a little bit of background, and then we'll open up the floor to audience questions and to more informal discussion. So at any point during the panel, feel free to drop questions and comments in the chat, and then once each of the panelists has had a chance to introduce themselves, then feel free to unmute yourself and ask questions that way and contribute to discussion that way. So, all right, that is all that I have. So Kurt, you can take it away.
Okay, I'm going to share my screen. I assume everyone can hear me?
Yes.
All right, very good. Let me share my screen here and share. So, little bit of background. In 2019, Brian Winkle approached me, and he wanted me to write a book for SIMIODE to illustrate how you could teach ODEs with modeling and applications right up front as the motivation before you start doing any theory. This was because we had spent 2 years together at Rose-Hulman, and he sort of turned me on to this approach for teaching ODEs, and I embraced it for 30 years, and I really liked it, so I said yes. So it was a nice, good COVID project. And the idea is not to do away with any mathematics, but rather illuminate them with applications, as we've seen so many talks already today, where people use applications profitably to motivate the mathematics and maybe even go farther with the mathematics than you otherwise could. So the mathematics, the applications are a hook for ODEs, and it helps students see the motivation for why they should study it. And I spent several years at NASA. I spent about 8 years in industry using ODEs and PDEs. And there was a lot of topics I saw that were important that I wanted to throw into an ODE book that's not typical. So things like dimensional analysis, scaling, parameter estimation, stuff on control theory, and model assessment. I threw all these things into the book. Not that you have to do all those things to use the book, but they're there in case students want to know more about them or you want to teach more about them. The textbook itself, I wrote in this pretext language, which is of some becoming more popular. The beauty of the pretext language is it can generate HTML files for the book, which is our main vehicle for disseminating the book now. Is you can an HTML version of it that's very interactive, but you can also get a print-on-demand version, traditional book. The text uses lots of SIMIODE modeling projects that I stole or adapted, and then actually about half of them are new that I wrote, and most of them come with data sets that you can use. And in fact, many of the exercises in the book have data sets as well. So there's the projects. There's also inline reading exercises that are sort of cursory checks of student knowledge as students go along. And those are in the HTML versions. The solutions to the reading exercises are there, but they're hidden. And the students can click on them and then check their knowledge as they go along. There's also traditional problems at the ends of the sections and the modeling projects, and solutions for the end of section problems and modeling projects. Those are available to some of them are available to students at the SIMIODE website. All solutions are available to instructors. There's an allied website that has a lot of additional data sets, and it has supporting code in Maple and Mathematica and MATLAB and Sage. The book itself has Sage cells in it that lets students carry out computations on the fly, and so they can do that when they're working through. And just in the last few days, the issue of is it compliant with web content accessibility guidelines? I'm happy to say the SIMIODE or the pretext people have taken some care to make it generate HTML that is as compliant as it can be at the moment. And so I am going through right now, and my hope is to produce a completely compliant version of it in the next couple of months. The main thing is making sure all figures have alternate verbal descriptions and just double checking whether headers are compliant and things like that. But the pretext people have said they are trying to make it generate compliant HTML. So that's a nice. I knew those standards were going into effect, but it hadn't occurred to me to check whether our book meets them. So I'm working on that. So that's my spiel.
Good. I unmuted now.
Yep.
Awesome. Sorry, the screen switched from one monitor to the other there on me when I wasn't expecting it to, and I'm like, where did my unmute button go? Hi, I'm Jean Marie Linhart. I'm a professor at Central Washington University. We are a public, non-selective regional university. We were originally a normal school, which means that we historically have trained and still train a lot of mathematics education teachers. We teach on the quarter system, and I teach a 3-quarter introduction to differential equations. A 1-quarter 3-credit introduction to differential equations. For those of you on the semester system, that is 2 semester credits. So we get through maybe 2/3 of the material that you do, and maybe less because we do not have a true engineering program. We only have engineering technology. The primary audience for the class right now, I think it's split between physics and secondary mathematics education majors, and I think the secondary education mathematics majors might be slightly ahead of physics. There are usually a few math majors, engineering technology, computer science, chemistry. Right now I have a chemistry major in the class, but enrollment challenges, frankly, are threatening the existence of the applied math major, and frankly, faculty attrition is as well. So one thing that's interesting about my class is that it really was a push. That the last redesign and the reason we adopted the book was because of our secondary education mathematics majors. And in particular, we needed to take them through the modeling cycle from I forget what the whole long name of the GAIMME modeling cycle is. And so I've been using the Falling Water project to do that, where we first do the Torricelli's law from the draining cylinder, then we go drain the cone, and when we drain the cone, we discover we don't have the right model, and then we have to go back and reevaluate our assumptions and go back through. So we just started that modeling project last week, and I think students have really enjoyed that project in particular, and it's really gotten them thinking. That has some very nice tie-ins for what they talk about in the secondary education classes. Physics majors love it too. Of course, there's lots of physics involved with that. I think one aspect of the book that was the biggest surprise to me was, I think the first quarter I taught it and we did the dimensional analysis. One of my students, I think it was actually, no, it was a physics student, and he was just like, why don't they teach us this in a much earlier class? This is amazing. This is useful. This is great. We should do more. That I don't know why we haven't been taught this years ago. So that's where I'm from, and that's what I'm doing in the book. I have a little more of a project-based focus, 3 tests, 3 projects. The projects are the modeling project, which is pretty big, communication, and then numerical methods and analysis project. The communication project asks them to explain the method of the integrating factor without using any formulas from the book, so explain the logic behind it. Numerical methods is the standard improved Euler Runge-Kutta 4, but then they have to do they generate, I give them code that will generate data tables for them, and then they have to reflect on the error formulas and what they're seeing in the error tables. That's all I got.
Hi, I guess it's my turn. Okay, let me share my screen. Yes, okay, so my name is Maila Hallare. I teach at the United States Air Force Academy, and we At the Air Force Academy, differential equations is labeled Math 245. It's 3 units, and we offer this course every semester. And during the fall semester, we have about 150, 170 students. But then in the spring semester, like right now, we have about 250 students. And this is a required course for all STEM majors. And so many of our students come from Calculus 3. They took Calculus 3 in the fall semester, but also there's a big chunk who come from Calculus 2. And so because of that, we have to design the course in such a way that we are mindful where they are coming from mathematically. So here what I have is so anyway, about the Air Force Academy. So it is one of the federal military academies, and every student graduates with an officer rank at the United States Air Force. They become second lieutenant once they commission into the Air Force. And so more than 60% of our students are in the STEM program. Okay, so I have here some, this is like lesson 3 that I have used a couple of weeks ago in Math 245. I just want to point out some of the slides here. In particular, this slide here has a table of values that I directly took from the SIMIODE textbook. For example, this is about modeling the hydrogen peroxide decomposition. And then we ask students to do some MATLAB parameter estimation using the Curve Fitter app in MATLAB. And so many students, I believe, appreciate this part of the course because I have heard from some of our chemical engineering students that they are now actually using MATLAB Curve Fitter because the chemistry professors have learned that we included first order chemical kinetics and second order chemical kinetics in our differential equations curriculum, which did not exist before. So we started using the SIMIODE textbook in 2023, and that's it. So I am because everything that I do, I was told, belongs to the government as a federal employee. Therefore, if you would like to have a copy of my slides, just feel free to contact me, and that's for public use. Thank you.
Okay. Hi, I guess I'm next. I'm Angela. I'm at USAFA. I'm actually one of Dr. Hallare's students. So hello again, Dr. Hallare. Good to see you again today. But yeah, I'm just gonna share like a couple of my like a couple of highlights from the book for me. So I'll go ahead and share my screen. So yeah, I'm mainly focusing on Sage and the hyperlinks today. And so like this is one of my favorite things about the textbook is that the e-textbook has Sage where you can this right here is a logistic model where you can really like you can alter the parameters, so like the carrying capacity, for example, the R, the initial population, and it's a really good way to be able to visualize it and be able to see like how changing certain parameters affects the function. And so on the left we have the original graph that the book or like the original code from the book, and then on the right is I just altered a couple numbers. And the other thing is computations. This is an example of the improved Euler's method, I think. Yes, the improved Euler's method. And yeah, it's just like it lists everything out very nicely. You have your time and your estimate. And then with that comes the commented code. And so obviously if you're just looking at this, like doesn't make a lot of sense. And so it's a good thing that we have this commented code here. And on towards like the top middle-ish, I like just screenshotted the formula for improved Euler's method. So especially like looking at that the first time could be very confusing. And so with the Sage code, like basically talking you through it step by step, it helps, at least for me, it helped me understand the content much better and much quicker. And then with this, you can also, same thing as before, like all the stage code is changeable, which means that you can toy around with it and it just helps you learn much better. And then the second thing, hyperlinks. And so the expandable references are great because like if you had those references all expanded originally, that's a lot of scrolling. But because they're just hyperlinks, you can click them open if you like if, for example, if I forgot what 2.2.10 was referring to, I could just click on that and it would show it. And yeah, I wouldn't have to scroll all the way back up to the original spot where 2.2.10 was posted. And then there's also expandable models for the hyperlinks. Once again, I'm like a person who does better with like visuals. I really like the models that are in this book. And so having, once again, a hyperlink for that model and not having to scroll back saves a lot of time and just a lot of space. It just makes everything nice and clean. Yeah, that's it for me. Thank you.
Okay, I guess I'm next. I also have one slide with some information, which I am unsure whether you can see that. Just hang on. This is not one here. Is this good? Okay, wonderful. So I'm Maryke van der Walt. I'm at Westmont College, and we're a 4-year liberal arts college in Santa Barbara, California. I'm teaching differential equations with linear algebra for the third time. It's a 4-unit course, but we do about 70% differential equations and then about 30% linear algebra. This is often happens for a class required for engineering majors, right? So I typically have about 20 to 25 students in my class. Yeah, and it's required for the engineering majors, also the physics major and the applied mathematics minors. We don't have an applied mathematics major, we've got a minor and it's required for them. What I've enjoyed most about using this book is just my students are really very eager to see applications. That is the number one request I get from students all the time. And so I really love that like the whole first chapter is devoted to applications. And I mean, I feel it's applications with a fresh take, right? It's like using Usain Bolt's like sprinting data as like a first or a first example of a first order differential equation, or like not your typical salt tank model. It's like drug delivery in the inner ear. And I just really like that it's just a fresh take on applications. And I've also really appreciated that the subsequent chapters, they typically start with like this kind of a grounding application of like, this is why we care about a second order differential equation, for example, or this is why we care about a system of differential equations, or this is why Laplace transforms might be helpful. And I've found it really helpful to be able to refer back to that to my students in the whole chapter to kind of keep them remember, this is why we are working through all this really hard math of the Laplace transforms, because we're going to be able to do this really cool stuff once we understand this well. Modeling projects also really, really nice. I typically assign about 3 of them in a semester. Last week, my students did the first one, and they did the shot in the water where they model the velocity of a bullet, right? Once it goes underwater, they use it to work out how far the bullet's got to travel once it's underwater to figure out if a person underwater will be safe from the bullet. And my students really enjoyed it. And I asked them in class like what they thought about it. And I heard various responses. Like one of them shared about this Mythbuster episode where they already saw some of this and they were really into it. And the other one was just so incredulous. He was like, what? I couldn't believe my results, and he wanted to hear what his friends got. And it was just really fun to see them like just engage with the mathematics and just what could be possible with the modeling. So I'm so glad, Kurt, that you're on the panel, and just thank you so much. This has been really lovely for me to get to know this book and to use it. That's me.
Okay, I think I'm up next. So I don't have slides per se. I do want to show you a little bit of what I do in my classes, but I want to talk a little bit about who I am first. So I'm Catherine Kozak. I am at Coconino Community College in Flagstaff, Arizona, and today we're excited because we actually finally got snow this year. I know the rest of you on the East Coast could care less, but we've missed snow all winter, so I'm really excited. I'm at a community college, so I'm a little different in terms of what we can and can't teach. We have to meet our articulation agreements with our state universities, and they don't necessarily totally agree with each other, so we have to kind of mix and match with what we're teaching to make sure it can go to all three universities. We have to use MATLAB because Arizona State University wants us to have MATLAB in our classes. So we have a lot of things we have to do in our classes. And I'm actually one of the earliest adoptions of this. I think I adopted it during COVID or during the COVID period. And so one of the first times. And what I want to do is I have a physics degree background, so I can bring that physics in. And I love the dimensional analysis part because that's what I do in physics. And I get to bring my students this idea. Most of our students are engineering students. So this semester I have a chemistry student and a student who's just taking it for the fun, which is so cool. Because I don't normally get that. And we only offer the class once a year. And we also only have, like this semester, I have 11 students. So we have very small classes. It's a very different, and we have to kind of meet what we're doing. And this is one of the things I give out to my students that the very first day of the semester. Let's see if I can get it to come up. I actually give this problem out, and I actually show them Usain Bolt's race. And I ask them after they watch it, and we watch it several times, and I say, can you show me, can you graph it about what's happening? And they get into this idea of what do they think is happening and how would they draw this? And then we actually go through the dash it all and we talk about what is happening and we develop this model. And this is the first day of the semester. And they don't know what a differential equation is. They don't know how to solve them, but we're just trying to get an idea of what do differential equations look like and why do we do them and where do they come from? And so this has been like my exciting thing I love to do on the first day. And then I do some of the other activities, and I actually use a lot. And I'm going to stop sharing because this is an exciting look at. I actually like to use some of the other SIMIODE modeling projects because I give take-home tests, and they're actually my take-home test because I think that they really bring things together. And so that's what I really love about the class. And I love this book. I just love that it brings the students into things. I have to add a few things in from other books because the book doesn't do series solutions and I need to do series solutions. So I just found an open source book that does series solutions. So it's not like my students had to buy another book for that. And it just brings it all together. And I just love it.
Awesome. Thank you all. AJ, I think you're up next. Is your internet working?
Yeah, I'm sorry. The internet cut out on my phone, so I hope it lasts. Um, but I'll try to be quick. Hello, everybody. My name is AJ Alnaser. Don't worry about pronouncing my first name. AJ is fine. I work at Florida Polytechnic University, and we are a STEM-only university. And I would say the majority of our students are computer science and engineering students. Those are the biggest schools we have. So we offer differential equations at least 4 to 5 sections per semester, including the summer most of the time. So, and we always have about, I would say about 25 students per class. So it's a large population of students that we serve. See if I can share my screen.
Okay, yep. Oh, this is cool.
So can you all see my screen now? And again, I do
Yeah.
apologize about the connection. I've been trying to fix the internet for the last 3 hours.
No,
You just
it's
picked the
great now.
perfect time to do this.
Yeah.
But I hope you can all hear me well now. But essentially, we adapted the PDF or the actual physical book when it was published first. I think we were among the first university to actually adapt the book full on for the whole class as the official textbook. And we really fell in love with it. So I coordinate the class, and we developed labs, like actual projects, bi-weekly projects. We developed six of them, and they're all very different, but they all accumulate into one big project. So they're all connected, kind of. Uh, and we had standard learning objectives for the class before and after. The learning objectives did not change, and you can see them here on the graph. To solve a first order EDE modeling problem, where basically we just give them a scenario and ask them to create a model. And these problems are assessed on an exam, so these are timed assessments. And you can see the results in blue, that's before, and the results in purple, those are after. So we've actually shown that teaching with a modeling first approach, like by the numbers, it's better. It works better. And we were very happy with these results. And we can see that, I mean, the trending average of the class was a C. Immediately after we adopted this method, it moved to a B, and it's been standing still at a B or a high B to an A average semester to semester. Now, again, this might sound a bit like kind of show-offish. I apologize. But we do have really good students, and it's a STEM-only school. So we have a lot of really strong students. And we offer the class to a very large population every semester. So we might be a little bit different than your regular like all majors college, or we have kind of a special group of students, I would say. They tend to do very well. What's enjoyable about this is we often get the data science students sign up for differential equations. Computer science students sign up for differential equations, even though it has nothing to do with their major. They are required to take an advanced math class just to kind of check a box. And most of them take other classes. A lot of them take differential equations, though, because they hear about it from the engineering students and they think, oh, this is exciting. I want to go see what they're doing. And we actually managed to recruit most of our applied math majors after they take differential equations. So they come in, most of them are engineering or some other major or physics. They switch to math soon after they take differential equations. I remember a student saying that this class blew my mind. Right now he's in a PhD program in math. So we're very happy with the results. Going back to the HTML book, so a lot of really good feedback, and I've been gathering feedback from, I haven't taught the class in last year. So I've been hands off, just basically I designed the class, built everything, handed over to other people. And I've been just collecting their feedback as we go, semester by semester. The people actually use the HTML book in class, during class. We have projectors and they're hooked up to computers, and we just go in, log in, and just pull the book as is. Instead of doing slides or writing notes or something, we just actually pull the book as is on the and start talking about it. It's very well designed. So thanks, Kurt. I really appreciate it. It's very well designed. We can actually use it to present in class, and it's very well constructed. There has been some issues with logging in and creating accounts on SIMIODE. So I've been hearing this repeatedly. Once people get on it, they kind of get the hang of it, and it's fine. But for new instructors, it's always been a challenge to create the SIMIODE login and create and access the textbook. So a lot of people kind of like find it frustrating and switch to the HTML, to the either hard copy or the PDF. But then they run into another issue, which is there is some discrepancy between the problems and the selection and the sections from PDF to printed version to the HTML. So that's been an issue that we've been kind of trying to adapt to. Let's see. There has been some particular asks, and I know these asks are very selfish, and again, because of our students and our population, but I have to make these asks because people have been knocking on my door and nagging me for a while to do this, so I'll just bring them up. So some of these asks are if we can get a little bit more description on the S domains for the Laplace transforms. Let's see, there has been a lot of people asking for a section on boundary value problems. And series solutions, those have been the biggest asks. We have a large population of our students that get out of differential equations, sign up immediately to partial differential equations. And they have to do a lot of catch up because they wouldn't have seen boundary value problems or series solutions. in the current like the current differential equations text. So those are things that we've been kind of doing our own thing and creating our own handouts, but we would like it to be all incorporated in one textbook. That would be incredibly grateful. We'd be very grateful for that. In terms of students' reactions to the book, they love it. They absolutely love it. We haven't, I mean, people feel, students, you know how during they have to do the student assessment of instructions at the end of the semester? I think all schools have that. Students feel obligated that they have to say something good about the textbook. As part of what part of the course do you like? The textbook, usually. Not the instructor, not the teaching, not the textbook. It actually always makes it into the thing that's positive and students love it. And I think also that the students' access to the HTML is actually easier than the faculty's access to the HTML for some reason. Again, I'm not sure, but I never had a problem with my SIMIODE account, but for new faculty, seems to have an issue. Let's see. The programming bits. A lot of people were incredibly happy with that. We use MATLAB heavily, but we have a lot of faculty that are familiar with Mathematica and Maple and all sorts of other languages or other like software that they like to use, and it's been wonderful just having access to all of these. So that has been always a very, very positive thing. We love that a lot. As I was saying, students show a lot of positive response. Right now, the current class average is in the 85% range on the timed assessments. So those are all exams, like timed exams. Most of the exams are done in class, so those are 50-minute exams. Yet students find it very doable. They actually can construct an entire model. They can solve a whole bunch of problems and do all of that within 15 minutes, and they're incredibly quick at it. They just have a much deeper understanding of what's going on, which is really fantastic. Let's see. I think that's pretty much it for me. Again, I'm very happy to share more data and more results if anybody in this is interested. But that's pretty much it for me. And again, I do apologize about the bad connection. I hope this came across clear.
It did. Yes, that was nice and clear. When turning off the video made a difference. And that data is incredible.
The graph I showed you is kind of an accumulation of about 5 years worth of work.
Okay. Yeah, we are at the top of the hour, so we are officially done. But if anyone wants to stay and keep chatting, you're welcome to. It's been an awesome hour. Thank you all for wonderful discussion and sharing. And yeah.
Thanks, everyone.
Thank you,
I'll be around
everybody.
tomorrow, too.
Thank you. Have a good night.